Good evening, all. Welcome to the Bidyasagar Classes. So, আজি ଆମେ hydrocarbons ଉପରେ topic ଉପରେ ଆମେ ଗୋଟେ multiple choice question କିଛି discussion କରିବା. So, active participation all the students is required. So, ସମସ୍ତେ actively participate କରିବା. So, first we'll start with the home assignment. So, previous class रे ମୋ होम असाइनमेंट दिया इतला decreasing order of reactivity towards the nucleophilic addition to carbonyl group among the cyclopentanone, 3-pentanone and 3-pentanol. So, you will see among the among the aldehyde ketones, aldehydes are more reactive towards the aldehydes are more reactive towards nucleophilic reaction. So, 3-pentanone, cyclopentanone and pentanol. So, N-pentanol will be more reactive than your 3-pentanone, then the cyclopentanol. So, in N-pentanol, in aldehyde, alkyl group is on one side. That is the structure, the aldehyde group. Only one side the aldehyde group is there. So, the incoming nucleophiles will attack easily. There is no hindrance because one bulky group is present. But in case of your ketone, in case of ketone, due to presence of two bulky groups, the incoming nucleophiles, the attack becomes difficult because due to hindrance, steric hindrance, so it is less reactive than the aldehyde. So, and cyclopentanone. So, in this case, because of more alkyl groups here, the reactivity again decreases. So, correct option will be the N-pentanol. B is the correct option. So, N-pentanol, then 3-pentanol and the cyclopentanol. So, this is the correct decreasing order because the aldehydes are more reactive than your ketone, and cyclopentanol is the least reactive. So, option B will be the correct. So, we'll go to the next slide. Okay. Okay, fine. Correct. In Wurtz reaction, the first question is in Wurtz reaction, If you take CH3Cl and the CH3C2H5Cl, then the product will be, good evening all, so you can concentrate here, okay. So you know the Urge reaction, so it is a very important reaction. If you will take CH3Cl plus 2Na plus ClCH3, it will give you CH3CH3, ethane, okay. If you will take C2H5Cl in sodium dry ether medium, it will give you butane CH3 CH2 CH2 CH3. Okay, so C is the correct answer. Fine. Okay, you got the answer. Okay. Okay, fine. Okay, we'll move to the next slide. Question number 2. Yeah. Reactivity of hydrogen atom attached to the different carbon atoms in alkanes has the order. So you know different order of reactivity will be your 3 degree, greater than 2 degree, greater than 1 degree. So because tertiary free radical is so reactivity of hydrogen is tertiary is more reactive than the primary. Primary is more reactive. Yeah, tertiary is more reactive than the secondary. Secondary is more reactive than the primary. This is the order because the reactivity of the hydrogen atom depends on the 3 degree free radical. So 3 degree free radical is greater than 2 degree free radical, which is greater than your 1 degree free radical. So the reactivity order would be this one. So 3 degree hydrogen atoms, the hydrogen atom attached to the 3 degree carbon atom is more reactive than the 2 degree. 2 degree is more reactive than the primary. So primary will be the least reactive. The option C is the correct answer. Okay, fine. Okay, good. So the reactivity order would be like this. Okay, so tertiary would be more reactive than the secondary. Secondary would be more reactive than the primary. Option C is the correct answer. Everybody are getting? Okay. We'll move to the next slide. Right. Full form in the description. Okay, and mobile numbers are also defined. Okay. Electrolytic cleavage in presence of AlCl3, electrolytic cleavage. So it will give you CH3 plus Cl minus, methyl carbonium, or so it will the electrophile generated, which will attack the benzene ring, to give the toluene. So answer is your CH3 plus is the correct answer. C is the correct answer, CH3 plus. Cl minus, and it will give you AlCl3 plus Cl minus, it will give you AlCl4 minus. Okay, so the correct answer is your CH3 plus. The CH3 plus, the electrophile generated is the CH3 plus in the Friedel-Crafts reaction. This is called Friedel-Crafts reaction. I think you would be knowing this reaction. So this is your Friedel-Crafts reaction. CH3 plus is the correct answer. Okay, fine, good, very good. Both. In the free radical chlorination of methane, the chain initiating step involves the formation of dash. Okay, so it is a very important reaction. You know, when methane reacts with the chlorine in presence of H mu sunlight, okay, it will give you mono halo derivatives, like it will give you CH3Cl plus HCl. Again it will react with Cl2, it will give you CH2Cl2, then CH2Cl2 plus Cl2, it will give you CHCl3, then CHCl3 reacts with chlorine and it will give you CCl4, carbon tetrachloride. Okay, so a series of reaction takes place by replacing one of the hydrogen, and it will give you monohalo, dihalo, trihalo and tetrahalo derivatives. Okay, so in this case, what is the first step? The chlorine atom in presence of sunlight undergo homolytic cleavage, and it will generate the free radical, chlorine free radical. This is the first. So it will generate the chlorine free radical. This will attack the methane and it will give you CH3 free radical plus HCl. Then the CH3 free radical attack the another chlorine free radical, attack the CH3 free radical to give you CH3Cl. So this is your first step. The chlorine free radical undergoes homolytic cleavage and it generates a chlorine free radical. So the option 1 is the correct answer, chlorine free radical. Okay, fine, very good, बहुत बढ़िया. So A is the correct answer, right? Fine, chlorine free radical. Okay, so it undergoes homolytic cleavage, right? Homolytic cleavage, right? This is called free radical chlorination of the alkane. This reaction is also called free radical chlorination of alkane, right? Okay, you will move to the next slide. Okay, I think all are getting. समझते बुझीचा? Right, very good, बहुत बढ़िया. Right. Which one of the following reaction is expected to radially give a hydrocarbon product in good yield? Question number 5. Okay, so I think, so they are the option, you know, the third one, C, CH3, chlorine H mu, it will give you alkyl halide CH3CH2Cl. It will not give a halo alkane. Option D, CH3 whole 3 CCl in presence of C2H5OH. It will give you nucleophilic substitution reaction. This is a halo alkane. So it will give you what? Tertiary alcohol. It will give you alcohol. This one also give RBr plus CO2 plus AgBr. Okay. So it is also give the haloalkane. So option A is the correct answer. Option A is the correct answer. Okay. So we'll discuss about this reaction. Okay, fine. This is the Cole's electrolysis, right? You know about this reaction? Okay, good. So option A is the correct answer. This is the correct answer. So what is this? RCOOK. It undergoes electrolysis. Aqueous solution of potassium salt of carboxylic acid undergoes electrolysis. It will give you RCO minus plus what? K plus. It will go to the anode and it will go to the cathode. Okay. So in anode, what will happen in the anode? What will happen? RCO minus lose 2 electron, 2 ions. Okay. It will give RCOO, 2 molecules which is unstable, which will give you RR plus 2 molecules of CO2. So this is your product hydrocarbon. This reaction is called Cole's electrolysis. Fine. Cole's electrolysis. In this one we will get the hydrocarbon. Other reaction will get the haloalkane. In this haloalkane we will get. In this also we will get the haloalkane. In this we will get the alcohol. Okay. So this is the correct answer. The option A is the correct answer. Fine. All are getting? Option A is the correct answer. Cole's electrolysis. Right? Good. We'll move to the next slide. Okay. So Bidyasagar Classes in Bhubaneswar providing the OUAT recording classes for more than 500 hours in only the rupees for 999. Those who are interested, you can fill the form in the description form in the Google. Okay. And the mobile numbers are also there. You can contact in this number. Okay. We'll move to the next slide. Fine. The reaction of ethyl magnesium bromide with water would be very important question. Okay, we'll discuss. So what is the ethyl magnesium bromide? What is this? Can you check? What is this reagent called? Anybody? Ethyl magnesium bromide. It's a Grignard's reagent. Fine. Have you heard about the Grignard's reagent? Right. So Grignard's reagent, when it reacts with water or active molecules with active hydrogen like ammonia, water, ethyl alcohol, CS3, CS2OH or CS3OH, all these compound with active hydrogen, it will react with the alkyl part and it will give you corresponding alkane. So it will give you CS3 because the alkyl group is the ethyl group. When the H is added to the ethyl group, it becomes a ethane plus MgOHBr. So which one is the correct one? So the option A is the correct one. Very good. Bahut badhiya. So not only water, any compound, any molecule with active hydrogen like ethanol, ammonia, water, okay, acetylene, okay, with active hydrogen, it will react with the alkyl part of the Grignard's reagent and it will give you corresponding alkane. Very important question. So you can, if the question is coming for the ammonia, water and CS3OH also, we can it will give the same alkane, only the side product will change. Fine? All are getting? Fine. We'll move to the next slide. On mixing, very important question, on mixing a certain alkane with chlorine and irradiating it with ultraviolet light, it forms only a one monochloroalkane. This alkane could be, okay, only one type of halo derivatives, means it should have only one type of hydrogen atom. So if you see in case of pentane, okay, in case of pentane, it is having 2 degree hydrogen, 2 degree hydrogen and 1 degree hydrogen. This is 1 degree. So it will give you two types of monochloroalkane. In case of isopentane, here it is 1 degree, it is 2 degree and this is 3 degree. So it will give you three types. In case of propane, it is having two types of hydrogen, 1 degree and 2 degree. It will give you two types. But in case of neopentane, okay, in case of neopentane, it is having only one type of hydrogen. So it is 1 degree. So it will give you only one type of product. One type of product, that is your neopentane. So it depends upon the type of hydrogen present in the alkane. If it is all the three types of hydrogen is present, 1 degree, 2 degree and 3 degree, it will give you three types of monohalo derivatives. If it is only two types are there, then it will give you two types of monohalo derivatives. And if it is one type of carbon atom is there, only one type of hydrogen is there, it will give you only one type of monohalo derivatives. So the neopentane is the correct answer. Answer C is the correct. Very good, very good. So neopentane is the correct answer. So option C is the correct. Okay. Fine. All are getting? We'll move to the next slide. So aromatization of the N-hexane gives, okay, N-hexane. So you know, so it undergoes aromatization and it will give you what? Benzene. It will give you what? Benzene. So this is the aromatization of the N-hexane. So it will give you the benzene ring. So B is the correct answer, right? Not cycloheptane. So B is the correct answer, right? because aromatization means aromatic, it will give you aromatic ring. So benzene is the aromatic ring. It will not give you cyclohexane and toluene, because you don't have the 7 carbon atom, you have only 6 carbon atom. So toluene it will not produce toluene. It will not give you cyclo compound because it will undergoes aromatization. So it will not give cyclo compound. So answer, the benzene is the correct answer. So the B is the correct one. Okay, fine. So option B is the correct answer. So this is called aromatization of an action. 6 carbon atom is arranged in an aromatic ring and it will give you benzene. It will give you benzene. Fine. Okay. We'll move to the next slide. All are getting? Good. So Bidyasagar classes in Bhubaneswar, OUAT, multicolor, 36 multicolor printed study materials are provided by your Bidyasagar classes at ₹7,000 rupees. Those who are interested can fill the form in the Google, okay, description. Okay, and contact this number which is present in the board. Okay, fine. So we'll move to the next slide. For the preparation of tertiary butyl methyl ether, which one of the following methods should be recommended? Very important question. So question number 9, very important. So here you have the two options. If the you have sodium alkoxide, tertiary sodium alkoxide, and with the CH3 beer. So this is a very strong nucleophile and strong base also. In this case, it will give you tertiary butyl methyl ether. It will give you tertiary butyl methyl ether. It will give you ether. It also causes the elimination also. It also causes the elimination to produce what? Alkene, to produce alkene. But the order of elimination depends on alkyl halide. Alkyl halide is 3 degrees more reactive than the 2 degree for elimination reaction. Then the 2 degrees more reactive than the 1 degree. Okay. So if we will take the reverse condition, okay. So in this case, this tertiary sodium alkoxide ion is more reactive and more, it's a very strong nucleophiles. So it undergoes nucleophilic substitution and it will give you tertiary butyl methyl ether. The ether is the major product. There is the ether is the major product and the alkene produced is the minor product. The alkene produced is the minor product because the reactivity order is of the different alkyl halide is 3 degrees more reactive than the 2 degree, 2 degrees more reactive than the 1 degree. So, but if we will take the reverse case, if the in this case, the alkoxide ion causes the elimination, it will give you it will give you the alkene. It will give you the alkene. So the correct option is the your B1. Yeah, not C1. This is the correct one. So in this case, it will give you the tertiary butyl methyl ether as a major product because it's a strong nucleophile. So because here the alkyl halide is 1 degree. So here no elimination takes place. Here the substitution is the preferred. So here substitution overtake your elimination reaction. तो यहाँ पे substitution so it will give you what? Tertiary butyl methyl ether. Okay, is the major product. Fine. C is the correct answer. Okay, fine. Okay, fine. We'll go to the next slide. There is no elimination takes place here because the alkyl halide is the primary one or 1 degree one. If it is tertiary, in that case, elimination takes place. Fine. So in this reaction, substitution takes place. Okay. So ether is the major product. We'll go to the next slide. Okay. In cyclopropane, cyclobutane and the cyclohexane, the common group is, okay, so you know the cyclopropane and cyclohexane, the CH2 group is the common, say cyclo compound. Each corner CH2 group is there, you know. So answer is your what? CH2. So option D is the correct answer. Methylene group, CH2 group. So in all the cases, the CH2 group is the very common group. Okay, option D is the correct answer. Fine. Right. Good. So option D is the correct answer. Right. Good, sir, Mr. Good. So question number 10, D is the correct answer because in all the cases, CH2 is the very common group. Right. We'll move to the next slide. It is a very easy question. Okay. Okay, so question number 11, propene, if you are giving HBr, you know about this reaction, this is the Markovnikov's rule, right? And in presence of magnesium ether, dry ether medium and with the water and well. Okay, we'll see. So propene, this is the propene. So in presence of HBr, what would be the A? See, it undergoes Markovnikov's rule. You know about the Markovnikov, the negative part of the addendum goes to that double bonded carbon atom having less number of hydrogen. So what is the negative part of the HBr? The Br minus goes to that double bonded carbon atom having less number of hydrogen. It will go to the CH. So what is the major product here? CH3, CH, Br, CH3, H plus goes to here. Right? So here, this is the Markovnikov's rule. With organic peroxide, it undergoes anti-Markovnikov's Kharas effect or the peroxide effect. That reaction is called. Okay. So this is your Markovnikov's rule. So this is your A. When it will give you, when we will give you the CH3, it is the Mg. In presence of dry ether, it will give you what? Okay, CH3, CH, MgBr, CH3, MgBr. So it's a Grignard's reagent. So any haloalkane, it will give you Mg triethermedium, it will give you Grignard's reagent, that we know. So it will give you, just we have discussed with the active molecule having active hydrogen atom. So it will reacts with the alkyl part of the Grignard's reagent, and it will give you what? So it becomes your propane. It will give you the propane. So propane is the correct answer. Fine. All are getting? Okay. So propane is the correct answer. So no butane, no propene, no ethane. So propane is the correct answer. So answer A is the correct. Fine. All are getting? Fine. Very good. Very good. A is the correct answer, right? Good. So we'll go to the next slide. So Bidyasagar Classes in Bhubaneswar providing 200 topic wise test in the answer with the explanation in the mobile app. So only just rupees 199. Those who are interested can give the details in the description form in Google. Okay, and the mobile number is there. You can contact in this number, right? So only just 199 rupees they are providing. So you can take the benefit from Bidyasagar Classes. Okay, we'll move to the next slide. Okay, very important question. Ozonolysis, right? Which alkene on ozonolysis gives CH3, CH2, CHO and CH3, C double bond O, CH3? I'll give you a trick, so we'll get the answer very quickly. Okay, so see here, first of all you have to write the product like this. See, what is the product? CH3, CH2, C double bond O, H. You have to write like this, plus C double bond O, CH3, CH3. So both the carbonyl groups should be placed like this. Okay. Now what you will do? You will just remove the oxygen part and just join both the part. So it is CH3, CH2, CH is there. You have to just put the double bond and the another group here, C, CH3. So you have to remove this part, oxygen part, and just join and put the double bond in both the carbonyl carbon atom. So you have to put the double bond between both the carbonyl carbon atoms. So we'll get the alkene. So your correct answer would be the A, CH3, CH2, CH, C, CH3, CH3. Okay. So this is the correct answer. Option A is the correct answer. Okay. All are getting how you will get the product easily. Any aldehyde and ketones, if it is given, you have to do like this. So you have to do like this. You have to just write the aldehyde or ketones in such a way that both the carbonyl groups should face each other, and just remove the oxygen part of the carbonyl group and put the double bond in between the carbonyl carbon atom. Okay. So we'll get the what? We'll get the alkane. Fine. So this is the ozonolysis reaction, you know very well. This product on ozonolysis, it will give you this product. Okay. Okay, fine. We'll move to the next slide. So aromatization of the N-heptane by passing over Al2O3 plus Cr2O3 catalyst at 773 Kelvin, it will give, already have done like this type of problem. Okay. So what it will give? So it is your N-heptane So it undergoes aromatization. It will give you toluene. So toluene is having 7 carbon atom. It undergoes aromatization to give the aromatic ring. 7 carbon atoms are there. So it will give the toluene. It will give you the. So toluene is the correct answer, right? Very good. Very nice. So B is the correct answer. So already you have done like this question. So aromatization, it will give you aromatic ring. Okay, 7 carbon atom is there. So it will give you toluene. So CH3 is attached to the benzene ring, that is called toluene. Okay, fine. So B is the correct answer. We'll move to the next slide. Okay, butene 1 may be converted to butane by reaction with. So it's a very easy question. Okay, so see here. CH3 CH2 CH double bond CH2. If you'll give PdS2, it will give you the pi bond will break and both the side you can put the hydrogen. It will undergoes addition reaction and we will get a butane. We will get the butane. See, it undergoes also reduction, but for the your carbonyl compound zinc HCl, zinc HGS also it undergoes reduction of the carbonyl compound to give the alkane, corresponding alkane. Okay, so SnHCl also. So this one only the convert the corresponding alkene into alkane. So SnHCl is the correct one. Sorry, PdS2 is the correct one. Option C is the correct. PdS2. You can give the nickel and S2. Okay, you can give nickel also. So hydrogenation. It is also called as, this reaction is also called as catalytic hydrogenation. So if we'll give hydrogen in place of catalyst, it is called catalytic hydrogenation. In place of palladium, we can also give the nickel or platinum. So this is your what? Catalytic hydrogenation. It will give you corresponding alkane. It will give you corresponding alkane. So option C is the correct answer. Very good. Okay. ओडिया कहवा ठीक है. Okay, we'll move to the next slide. So Bidyasagar Classes providing the OUAT 10 mock test 2000 MCQs. Okay, so we'll get the 2000 MCQs, just rupees 499. Okay, so those who are interested can fill the form in the Google description form and the contact number is there. We can contact in this number. Okay, so just for 499 rupees, we'll get the 10 mock test with 2000 MCQs. Okay, we'll move to the next slide. So question number 15, C6H5CH3. So this is yours. This is your toluene. When toluene is treated with chromyl chloride, it undergoes oxidation. It undergoes oxidation to give benzaldehyde. What is this reaction called? So what is this called? This reaction is called ICAR reaction. So this reaction is called ICAR reaction, right? So toluene is oxidized by the chromyl chloride and it will give you benzaldehyde. So benzaldehyde is the correct answer. So option A is the correct. So option A is the correct answer. ICAR reaction, right? Very good, Chiranjeevi. Okay. So it's ICAR reaction. So it is there. So aromatic compound can be oxidized like toluene to corresponding your benzaldehyde aldehyde compound. So by the chromyl chloride. So that's a oxidizing agent. This reaction is called your ICAR reaction, right? So we'll move to the next slide. So when alkene is treated with your alkaline KMnO4, cold alkaline KMnO4, so that is it will be oxidized in presence of water. So it will give you S2O2 and it will be added to the double bonded carbon atom. So this side one OH group and this side one OH group. So it will give you ethylene glycol. So this is the product. So ethylene glycol is the product when we are giving alkaline KMnO4. Acidified KMnO4, it will give you aldehyde, okay? Mixture of aldehyde it will give. So if we are giving alkaline KMnO4, so it will give you ethylene glycol. Both the OH group is attached to both the double bonded carbon atom. So this is your product. So answer C is the correct answer. Fine. So C is the correct answer. So ethylene glycol it will give in the presence of alkaline KMnO4. So it is oxidized to give ethylene glycol. Option C is the correct answer. Fine. All are getting? Very good. So we'll move to the next slide. So again the related to ozonolysis reaction, okay? So we'll discuss again. We have to find out the compound. So a compound acts on ozonolysis followed by reduction gives an aldehyde C2H4O. So you have to see which compound that is, okay? C2H4O means CH3CHO, right? CH3CHO is the first aldehyde and the ketone is your butanone 2, butanone 2. So this is your acetaldehyde. So you have to find out, so which alkene on ozonolysis give these two products. Yeah, just you have to find it out, okay? You have to write like this. So you have to remove both the oxygen atom of both the carbonyl carbon atom and you have to put the double bond in between the carbonyl. CS double bond C CH3 CH2 CH2 CH3. So this is your principal chain. 1 2 3 4 5 6. So 3 methyl hex 2ene. So 3 methyl pentene 2 hexene 3 methyl so the double bond should be, so right, 3 methyl pentene 2. Good. So 1 2 3 4 5 6. Sorry. So I have done a mistake. So okay, so answer is this one, 3 methyl pentene 2. So is the correct answer. A is the correct answer. Okay, CH3 CS double bond C, CH3 CH2 CH3. So 5 carbon atom with, so pent 2ene. So 3 methyl pent 2ene is the correct answer. So option A is the correct answer. Okay, so right, good. So correct answer is the option A. Fine, you have done this kind of question once again. 4. Okay, we'll go to next slide. Okay, so Bidyasagar Classes providing the OUAT chapter wise notes and 15,000 MCQs with answer and explanation with just rupees 249. So those who are interested can fill the description form in Google. Okay, we'll move to the next slide. Identify the product P in the following reaction. Right, so see here again, CH3 CH double bond CH2 plus NOCl. So here NO plus plus Cl minus. Cl minus is the negative charge, it will possess the negative charge. Again the Cl minus will attack to those double bonded carbon having less number of hydrogen. So it will undergoes Markovnikov's rule. So what would be the product? Okay, so option B is the correct answer, right? Option B is the correct answer. So this is the, again the Markovnikov's rule, the negative part of the addendum goes to that double bonded carbon having less number of hydrogen. So Cl minus the negative part, NO is the positive part. So option B is the correct answer. Fine, all are getting? Okay. Ammonical silver nitrate. Question number 19. Ammonical silver nitrate forms a white precipitate easily with. So always the ammonical silver Ag NO3 solution, which will reacts with the alkyne with active hydrogen atom. So in case of this CH3 C triple bond CH This hydrogen is acidic in nature. It can be easily replaceable. So it will react with the AgNO3 solution and it will give you silver acetylite. Okay. So any other of the alkane, it is not there. Acidic hydrogen is not there in this. Here also. So this is your correct answer. So A is the correct option. Okay. Because it is in the active hydrogen atom. The triple bonded carbon atom having hydrogen is more active. It can be easily replaceable by the metal. So this is the correct answer. Option A is the correct answer. Good. Option A is the correct answer. All are getting? समझते बुझी होची ना? Okay, good. So we'll move to the next slide. So last question, question number 20. When acetylene passed through a dilute H2SO4 in the presence of HgSO4, the compound formed is. Very important question. See here. So in this case, only one molecule of water molecule is added to the triple bonded compound and it will give you corresponding enol CS2 double bond CHOH. This is the enol form which is converted to your keto form. So the H will come to here and the double bond will come to here. So it will be converted into CH3, C double bond O, CH. So acetaldehyde. So option B is the correct answer. So option B is the correct answer. Okay. So this is what called keto-enol tautomerism. Keto-enol tautomerism. So this is called keto-enol tautomerism. So acetaldehyde is the correct answer. Very good. Good. So in presence of H2SO4 and HgSO4, only one molecule of water is added to the acetylene and it will give you corresponding enol compound which is converted to the corresponding keto compound which is unstable, which is converted to keto compound, that is your keto-enol tautomerism. You know about that. So all are getting? Okay. So this is the last question. So the last assignment, you can take the home assignment, this question, okay, and comment your answer in the chat box. Aromatic compounds burn with sooty flame because they have a ring structure of carbon atoms, they have a relatively high percentage of hydrogen, they have a relatively high percentage of carbon, they resist reaction with oxygen of air. So you can comment the answer in the chat box. Okay, fine. So next class we'll discuss regarding this. Okay. Thank you all for all your participation. Next class we'll meet again with some more MCQs with the hydrocarbon chapter. Thank you all. Okay. So like, share and comments करवे जो ने. Okay, so जो ने attend करचंती, so you can like and share and the comments on the live video chat and share with your friends. Okay, so they can also participate in the classes. Okay, thank you all. One.